Hello, welcome to another creative coding video. Today we're going to take a simpler look at the idea of nested loops or loops within loops that we introduced last time. Now it can be quite a tricky subject for some people, including myself, so it's worth kind of looking at it again and using a much simpler example just to help us kind of really understand what's going on. So the first video we did, the last video, was a bit more comprehensive for people who kind of get the idea really easily. But today we're just going to strip it down to just some real basics. So let me take a simple example of drawing a row of circles across the middle of the screen. Now mine are not circles, imagine that they are, and we could write 1, 2, 3, 4, 5, 6, 7, 8, 9. Are there 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, there are 9. 9 instructions, just 9 circle instructions. That's not very efficient, which is why you know that we can use a repeat instruction to repeat code that does a similar or the same thing. We also know that these are going in a row, which means that the vertical coordinate is the same. They're all 300 down, which is nice. But across, the position starts at 200 and ends at 600, and they're going along in steps of 50. So from here to here to here to here, the jumps are 50. So let's code this. This isn't new, we've done this before, but it's just good to go back to a place that we're familiar with. So I'm logged into Open Processing as usual, and I've enabled the Simple.js library, and I've got my setup with Simple. So I've got a very simple draw function here, and you can see a repeat instruction which calls the spot function, which we've written out here. Now this repeat instruction uses a loop counter which starts at 200, goes up to 600 in steps of 50. And when it runs spot, when it calls spot, it passes that counter and it becomes this variable x. So when we draw a circle, x across, 300 down, size 30, we should get a row of circles. Let's see. Fantastic, that worked. Now this shouldn't surprise us, we've done this lots of times before. Now let's go on to the next step. Let me clear the screen a little bit. Now imagine that we wanted not to have just a row of circles, but we wanted to fill a whole area with regularly spaced circles, like this, and on and on and on, and it will take me ages to draw them. But if I wanted them to start at 100 across and finish at 600 across, just like before, but 200 across, finishing at 600 across, but downwards in the vertical direction, starting at 100 and going down to 500. So that's quite a lot of circles to draw. And as I say, we definitely don't want to use lots and lots and lots of circle instructions. So we know the repeat instruction is really helpful, but can it help us here? Well, let's think about it. We could use a repeat instruction to draw one row like this. We can do that, and then we can use another repeat instruction to draw another row like this. That's possible, so we'd have 2 repeat instructions. We could do that again, but actually that's not very efficient because we'd end up with lots of repeat instructions. And one of the important points about coding is we don't want to write code that's laborious if we can avoid it. The whole point of computers and code is that it makes these laborious tasks easier. So is there a way to do it? Well, let's have a think. So we know that across we're starting at 200, going up to 600 in steps of 50. We know that downwards, starting at 100 and going down to 500 in steps of 50. So we're drawing a circle at almost every combination of those two loop counters. And yes, so the answer is yes, our repeat instruction can help us, but we use it in a different way. Let's see. So we have two loop counters now. We're going from 200 to 600 in the horizontal direction, and we're going from 100 to 500 in steps of 50 in the downward direction. Now this isn't two separate loops. This is a new kind of thing, which I'll explain later, but it's called a loop within a loop, or a nested loop. Let's see the effect first, and then I'll come back to explain what it's doing. So we have two counters now. One starting at 200, going up to 600 in steps of 50. The next one is starts at 100, goes up to 500 in steps of 50. And the two counters need to be accepted by our function. So we need to add another variable here. We could have called them A and B, or C and D, or I don't know, apple and banana, but X and Y makes sense here. So X will go from there to there, and Y will go from there to there. So let's draw the circle at X and Y. And remember I said this is going to go over every combination of the values. Let's see the effect. Ta-da! Cool. So we know that this kind of loop covers a whole area working in two directions, and for every point, for every combination, every possible combination, it calls a function. So that's really cool. Now if you want to understand it in a little bit more detail, let's see what's happening. Let me just clear some space on my drawing. We have one loop which is going across. We've seen that before, regular loop. What we're doing now is for every item in that loop, we run a new loop from start to finish. So this new loop will draw in the other direction. It doesn't actually have to draw, it's up to us. It doesn't have to go in the other direction, it's up to us. It's just counting with a new loop counter. So once this loop is done, we move on to the next item in the first loop. And then for that one, we run the loop again, the second loop, loop 2. When that's done, we go back to the next item in loop 1 and we run loop 2 again, and so on and so on. So you can see that the second loop is run from start to finish for every item that the first loop visits. And that's why we get every combination and we can cover a surface. So it's a loop within a loop. Loop 2, this one, let me just write that down, loop 2 is within loop 1. Okay, so that's all actually that we needed to cover in terms of the very basics of nested loops or loops within loops. But I'm going to continue now just to have a little bit of fun, just to show you just a simple example of the kinds of things you can build on top of nested loops. So I've got those circles and they're in a nice grid, What if I only drew circles if they were a certain distance or less from the center? Let me explain what I mean. So this is the center of the canvas at 400, 300, and I pick any spot which is at X, Y. Remember, X and Y will be changing so that all of these spots will be visited. Now the distance from here to here is what I'm interested in, and it's easy to work out. In fact, there's a function that does it for us. So when it's X and Y is over here, that's the distance. If it's close by, it's just that distance if this is the spot we're looking at. If it's very far away, like here, that's probably the furthest point and the distance is big. So let's work out that distance. So let's say var d equals, let's fix some of these indents. Dist is the function for working out the distance between 2 points. We're working them out between the point at xy and the middle of the canvas. That'll be the distance. So we can say if the distance is less than, let's say 200, only then draw the circle. So if does a test and says if d is less than 200, draw the circle. If it's not less than 200, it won't draw the circle. What does that mean? So this distance here, the long one, or the one to here, is going to be more than 200 because from here to here is 200. So from here to here is 200. So this one is more than 200, so it won't be drawn. So we'll draw across there. This one here is closer than 200, and it will be drawn. Tick. Let's see what that looks like when we do that test for every one of these spots on the grid. Okay, so some of them are missing now around the edge. But it doesn't really look like a circle. I was expecting a circle. Maybe if I made the grid more fine-grained, so the spacing is now 20 and the circles are smaller, say 10. Let's see what that looks like. Yep, that's closer to a circle. So you can see there are areas where no circles, no spots are being drawn. So all of these spots are at a distance 200, so less than 200 from the center. What does that look like? To me it looks like a kind of a diagram of a nuclear reactor with the control rods. Let's do some colouring. Let's use that distance. Let's say fill, and remember we're using the default red, green, blue, which means the values go from 0 to 255. D's not going to be more than 200, so we can use that safely. Let's see what that does. I don't really know. Cool, that's rather nice. Pretty cool. Let's see what happens if we could colour the outline of the circle, but the other thing we could do is change the width. Let's make that depend on D as well. So stroke width. Just as an experiment, if I said y divided by 100, so the width depends on the height, just to see what that does. Oops, there's some error, spelling mistake. It's not width, it's weight, isn't it? Stroke weight. Let's try that. Okay, so thicker at the bottom, thinner at the top. No, that's not what I wanted to do. Let's make it depend on D. So it depends on the distance from the center. Let's say divide that by 100. Okay, So they're very thin in the middle because D is small, getting thicker on the outside. Not sure I like that actually. Let's invert it. So instead of D, we have 255 minus D, 200. So now 200 minus D will be bigger in the center. Yeah, that's bigger in the center, thinner on the outside. If I make that 300, then it will be thicker all round here. And if I don't divide it by such a large number, then okay. What if I made the color of that outline stroke, say, yellow? Red hot yellow, a yellow hot yellow. Wow, okay. That's pretty cool. That does look kind of unstable and hot. So we can play around with this, you know, we can change the different kind of numbers just to kind of see if we can kind of get a nice balance. That's nice. I think I'll leave it at that one. The point is not to kind of this wasn't to really see kind of how the colors work. But the idea was to say, look, here is an interesting design and it could be improved further, sure. But it's based on a grid of circles, and we didn't write lots and lots of circle instructions to draw these probably hundreds of circles. We didn't even use lots of repeat instructions. We just used one powerful repeat instruction, which has the ability to cover an area, and it's using this new idea of loops within loops, or nested loops as some people call them. So as you learn more about coding in the future, you'll realize and you'll use nested loops a lot. I'm pretty certain of that, because they are so powerful. They allow you to kind of visit every combination of two different counters, and that can be used in all kinds of ways. This was a simple example, so we didn't do anything particularly sophisticated, but it's still pretty cool. Let's see what happens if I make the background just a bit darker. Let's say background, oops, let me type that properly. So I'm using a number this time just for a grey value. It's kind of dark. Oh yeah, I like that. Very cool. Yeah, that's definitely some dangerous stuff going on there. Okay, I'll stop there. What I suggest is if nested loops or repeated or loops within loops are new, and they are kind of feeling a little bit unfamiliar, and you're having maybe some trouble understanding them, the best thing to do is to experiment. Go back to your code, start with that simple example of one loop, a normal one, and then extend it with a second counter like we did, and just experiment and play. You might do experiments that say, what happens if we change the step size in a certain direction, like this? That's pretty cool. You see how along in the horizontal direction the step size is still 20, I think it was, and downwards now it's step size 60. So 20 across, 60 down. Or we can make them really tiny, so they're packed together even tighter like that. That's quite a nice design. Maybe I'll keep that. Yeah, I'm too tempted to keep playing with this now. I should have somebody to tell me to stop. I like that. I'll settle on that. Yep, I'll settle on that. So yeah, have a go. Keep experimenting and playing, because that way the nested loops work really sinks in through your actions rather than reading about them or listening about them. So have fun, have a go. If you'd like another attempt at a simpler explanation, do get back to me in the comments, and we'll create another video that just focuses on the difficulties that you might be having. It's worth persevering, because this is a real foundation for doing lots of really interesting code. So don't be shy about getting in touch. Okay, cheers.